So, today I'm going to be talking to you about the preliminary results of my thesis entitled Assessing Genuine Imposed Facial Expressions and Response Inhibition in Psychopathy. So, psychopathy describes a set of atypical personality and behavioral traits which may be broadly split into two factors, primary and secondary psychopathy. Primary psychopathy is characterized by callous unemotionality in terms of their affect, low levels of anxiety, and average outcomes on tests of inhibitory control. Primary individuals have been reported to have a low neural response to fearful faces. Additionally, a recent study has found such individuals have difficulties differentiating between genuine imposed emotional faces. In contrast to primary, secondary psychopathy is characterized by high anxiety, low impulse control, and its disinhibited, emotionally reactive nature. They've been shown to have poor outcomes on tasks designed to assess response inhibition. Furthermore, they've been found to have high neural sensitivity to fearful faces. Secondary is not associated with difficulties differentiating between genuine imposed emotional faces. The focus of my study centers on emotion identification, the ability to accurately classify emotions into distinct categories, and response inhibition, the ability to inhibit inappropriate behaviors in the context of psychopathic traits. To assess emotion identification, I created the genuine imposed emotional face task using ePrime software. In this task, participants viewed fearful and angry faces on a monitor and pressed designated buttons which classify faces as either authentic or fake. To assess response inhibition, we used an emotional face go-no-go task and EEG methodology. In this task, when participants see a go stimulus, they have to press a button. And when they see a no-go stimulus, they mustn't press a button. That is, they withhold the response, and this interaction is a measurement of response inhibition. Fearful and angry faces are the no-go conditions, while calm male faces are the go control condition. The use of EEG allows us to observe participants' neural response to emotional phases, as well as their activity during no-go trials and mistakes. My research aims to investigate three main research questions. 1. Do people high on primary or secondary psychopathy show reduced accuracy in judging genuine versus posed emotional faces? 2. Do people high on primary secondary psychopathy show differences in emotion modulation of response inhibition at the behavioral level? And 3. Do people high on primary secondary psychopathy show differences in motion modulation of response inhibition at the neural level? This would be using the EEG. I hypothesized that primary individuals would experience difficulty differentiating between genuine and posed faces and would not be influenced by emotion modulation during the go-no-go tasks. Moreover, they would have average response inhibition and show increased N2 and reduced P3 waves, and reduced neural responsivity to emotional faces. In contrast, secondary will not experience difficulty with the EI task, yet they will make greater errors and be influenced by motion modulation during the go-no-go task. Finally, secondary should have reduced response inhibition, greater neural response to emotional faces, and show reduced N2 waves and larger P3 waves. So now I'll go into a little more detail about the assessment tools I'm using. After the participants signed the consent forms, they completed two questionnaires. One is the PPTSR, which assesses general psychopathy, and the LSRPS, which specifically assesses primary and secondary traits. Then they will complete the behavioral task. The emotion identification task assesses the percentage of correct responses, response times, and the category of the missed faces that is genuine or posed. After this task, the go-no-go tasks are completed with EEG methodology. EEG records electrical activity along the scalp using a net of 128 electrodes with sponges at the end. The electrodes measure voltage fluctuations resulting from current flows within the neurons of the brain. When we apply the net to the participant, we show them their neural activity, as you can see on the screen. We ask them to blink and grit their teeth to show them the importance of keeping still during the tasks to ensure that we have the cleanest possible data, and also to make sure that we're able to remove the eye blinks with data reduction at a later date. These high amplitude waves that you can see here, these here are eye blinks. Then they also have a corresponding negativity, which you can't see. Here's an example of teeth gritting. It's horrible and I hate it. And here's an example of a very noisy electrode, which can be adjusted by rewetting the net, but not too much to avoid bridging. As participants complete the tasks, we continuously monitor the electrodes and the recorded data and make any adjustments that are necessary, like rewetting the net. The entire process takes between 2 and 2.5 hours. So far, the results of the study are preliminary, as we only have data from 12 participants, all of whom were CVU students of various disciplines. The age range was restricted from 18 to 25, with an average age of 20 years. Ethnic diversity may play a role in emotion recognition if participants are unfamiliar with the ethnicities of the people in the photos. Our task includes a wide range of ethnicities, and finally, 3/4 of the participants identified as female. Concerning the LSRPS, the mean primary score was 28.6 and the secondary score was 22.5. Within the PPTSR, the mean score of affective responsiveness and interpersonal manipulation were very high, while egocentricity and cognitive responsiveness were much lower. Affective responsiveness and interpersonal manipulation correlated highly with primary but not secondary psychopathy, while cognitive responsiveness and egocentricity did not significantly correlate with either one. these subcategories will be explained further on the poster, which you could see tomorrow if you go to the thesis presentations. Concerning the research question, the first one, the results of the EI task yielded no correlations between scoring highly in psychopathy and making greater or fewer mistakes in classifying cases as either genuine or posed. Paired samples t-task was completed, finding no significant differences between the mean, genuine, and posed % correct scores. Furthermore, the number of correct classifications were exactly equal for each condition. The results might change with additional data. So far, the preliminary correlation results for the second research question are available. There were significant correlations between cognitive responsiveness, which is the ability to understand other people's emotional states and engage with them, and angry no-go and male no-go stimuli, with a p-value of less than 0.03 and 0.02, respectively. Hopefully, with more data, this correlation will be further filled out. Additionally, we found significant correlations between primary psychopathy and the reaction times of angry and fearful no-go stimuli, with p-values of 0.01 and 0.05. The control trial, the calm phases, the middle no-go, was not significant. This result suggests that the response speed of individuals scoring highly on primary psychopathy were affected by emotion modulation, as they responded much faster in this condition than to the non-emotional condition. Concerning the third research question, we do not currently have EEG results analyzed. When we do, we will observe the N2 and the P3 waves, which will provide information about performance monitoring and inhibitory control, particularly. We'll be looking into the differences between the go and the correct no-go N2 and P3s. Thank you.